Okay, so welcome back. We'll be talking about arrays in chapter 7. And arrays are a variable that can store multiple values of the same type. So an array can store multiple values of integers, multiple values of doubles, characters, whatever, okay? But they all have to be the same type in an array. These values are stored in adjacent memory locations. So if I was to make a crude text representation, it might look something like this, right? Let's say that I have an array of 5 integers. Okay, so in memory, these integers would all be right next to each other. Okay, oops. And maybe it would look something like this. Okay. Just 5 values that are stored right next to each other. Say the first element has 75, 33, 22, 87, 66, or something like that, right? So these are just values that are all sequential. They're all adjacent to each other in memory, and they're all the same data type. Okay, so let's look at how we would declare an array. All right, so let's say that I wanted an array of integers, like I just pointed out in my crude drawing there, right? So I might do something like this. I might have an integer array. I'll name it tests, and I will give it 5 elements. Okay, so with this declaration, I now have an integer array that has 5 elements. Okay, so we have a data type of the array, we have the name of the array, and this name is just any standard identifier. Okay, we can name it anything we want, just like we can with other variables, subject to these identifier rules, right? They can't start with numbers, for example, or exclamation points or commas, okay? And the final piece that we have in between these brackets is what's known as the size declarator. And the size declarator is an integer that we specify that determines the size of the array. All right, so when I talk about size of the array in this context, I'm talking about how many elements there are inside this array. So the length of this array, maybe a better way to put it would be the length of this array. The length of this tests array is 5 elements. If I change this declarator to 10, the length of this array is now 10 elements. Okay, we'll have 10 values stored together adjacent in memory. Okay, but if I want to talk about how big an array is in terms of its size in bytes, you know, like integers have, they are variables or data types that are 4 bytes typically. A Boolean variable is 1 byte, a character variable is 1 byte. Well, arrays are going to take up space memory too. They're going to have a size. And so the way we can determine the size of an array is we just take the data type of the array and then multiply that times the number of elements of the array. Okay, so we configure the size of this array, this tests array, by just using this formula. Okay, the size in bytes equals the size of the data type of the array times the number of elements in the array. Okay, so in this case, I have integer, right? And integers are typically 4 bytes. 4 bytes times 10 elements. So the size of my tests array in bytes is going to be 40 bytes, right? So pretty simple. All we do is we just multiply the number of elements times the size of the data type of the array. Okay, so as another example, let's say I had a character array, and let's say I called it name. Right? And it has 20 elements. Well, the character data type is 1 byte, and name, okay, this name array has 20 elements, right? So this is going to be 1 byte times 20 elements equals 20 bytes. Okay, so that array is taking up 20 bytes of memory. And remember, this was 4 bytes times 10 elements equals 40 bytes. Okay, so it's pretty simple. I mean, it's just a simple multiplication. Okay. All right, so in addition, well, a general programming practice, a good idea, is to use constants for size declarators. Okay, so what we can do is we can say, we can say something like const int size equals 10. Okay, and then if we replace these literal declarators with our size declarator here, or with our constant size declarator, then both of these arrays are going to now be 10 elements. Okay, are both going to contain 10 elements. And if I want to change both of them on the fly, all I have to do is change this right here. Okay, so now both of these elements will, or excuse me, both of these arrays will contain 3 elements. Change it again, they'll both contain 20. And we'll see how this can be useful later on when we get to for loops and using for loops with arrays. All right, so generally we want to use this constant integer for our declarator, and declarators have to be integers. All right, and when we declare an array, they're going to have a data type, they're going to have a name, and they're going to have a size. All right, so the next thing we can talk about is how to access these arrays. Okay, the elements of the arrays. Okay, so let me comment this stuff out, and we'll move on. Okay, all right. I'll change this back here so this is consistent. Okay. All right. So let me redeclare my tests array, and I'll make it size 5. Okay. So if I want to access the first element of an array, I use what's known as a subscript. Okay, and so subscripts, they begin at 0 and they go up through the length of the array minus 1. All right, so if this is my tests array, this is my tests array. Okay, the first element is going to have a subscript of 0. The second element is a subscript of 1. Third is 2. Fourth is 3. And the last is 4. Okay, so it begins at 0. It goes up through n minus 1, where n is the length of the array. All right, and we can use these elements just like we would any other variable. So let's say that I want to assign 75 to my first element. Well, what I do is I take the name of the array and I take the subscript corresponding to the element that I want to assign the value to. Okay, so now 75 is going to be stored in the first element of this array, right? And so to prove that this is the case, I'll go ahead and print it out. Test 0. Okay, so now if I compile and run this thing, you can see that 75 is what's displayed, right? I stored 75 in the first element, and then I displayed the first element to my output. Okay. All right. So in addition to that, I can ask the user for a value and store that in the array. So enter a test score or something. Okay. And then I can go cin tests 1. Okay, and then I can do this, cout test scores equals tests 0, put a space in there, and tests 1. All right, and let's not forget my cin ignore, because I'm doing a cin statement now. Okay, So what's going to happen now is that 75 is going to be stored in the first element of the array, right? Just like it was before. And then I'm going to be prompted to enter a test score, and then I can enter whatever integer I want, and it'll store it in the second element of the array, which has a subscript of 1. Okay. Then once that's done, we'll have the cout statement here, which will print out the contents of test 0 and tests 1. So let's try it. Okay, so there's the 75 being displayed from before, and let's enter my test score. Let's say this person got 95%. Okay, so there are the values stored in the first two elements of this array. Right? So, in addition to assigning values and retrieving them, we can treat these values, these elements of this array, just like we can any other variable of that data type. So I could do something like this. The average of the test scores is, right? And then what I'll do is I'll find their average. Tests 0 plus tests 1, and then divide that by 2. Okay, so now when I run this thing, I should see the average here. Okay, bam, there we go. And I made it 75. I made them both 75 because they're integers. I'd lose the floating point else otherwise. So why don't I go ahead and change this to a double? So that way I can enter in whatever I want and not lose the floating point. Okay, so now we'll say 30. So now we'll say 74. Okay, so there's the average of the two scores that are stored in the first two elements of the tests array. Okay, so when we want to print the contents of an array, this is how we have to do it. We have to print them out one by one, okay? We can't display the contents of an array just by sending its name to cout. Okay, that won't work. And the reason is that the test's name, this points to the memory location of the first element of the array. So that's what it's going to return. It's going to return the memory location in hexadecimal of the first element of the array, not all the values in the array. Okay, so we'll see what happens when I do that. Okay, see, so this is the hexadecimal address of the first element of the array. Okay, if we want to, again, if we want to view the contents of an array, we have to print out each element individually. Okay, so program 7.1 gives us an example of, block this stuff out. It gives us an example of entering values into an array and printing them all out. Okay, so let's do that. Let's do something similar. Double hours, and let's say there are 5 workers. Okay. So I can prompt the user 5 times. Enter hours worked for employee 1. Okay. Oops. And we'll send 2 hours 0. Okay, notice this employee 1, that's what I'm referring to it as, but the subscripts, remember, they start at 0, so this is going to be off by 1 here. Okay. Alright, so we'll just copy and paste this 4 more times. 1, 2, 3, 4, and then I'll just update these subscripts. Okay, 1, 2, 3, 4, and my employee number. 2, 3, 4, 5. Okay, so what will happen when I run this is that I'll be prompted 5 times to enter in some hours worked for these employees, and I will enter in 5 values. All right, but when I'm done with that, I want to display it. Okay, so I will just do this. 5 cout statements. Employee 1 worked this many hours. So then I can just copy and paste this 4 more times. And I'll update my subscripts like I did before. 2, 3, 4, and the employee number. 2, 4. Okay, so it's going to prompt me 5 times. I'm going to enter in 5 different hours worked. It's going to store those hours that I enter into the appropriate element of the hours array, and then once that's finished, it's going to display the contents with a series of cout statements. Okay, so let's run it and see what happens. Okay, so my first employee worked 30.5 hours. My second employee worked 27. My third employee worked 33. My fourth employee only worked 17, and my last employee worked 31 hours. Okay, bam, there we go. So I entered in all the values, right, all the hours. They were stored in each element of the array, and then I displayed the contents of each element of the array. Okay. All right. So what if I want to do something a little bit more interesting? Let's say that I wanted to display the total hours worked by all my employees. Then I could do this. I could say, let me see here. I'll make a new variable here. Hours worked equals hours 0 plus hours 1 plus hours 2 plus hours 3 plus hours 4. Okay, so now I will display this. Okay, so now I'm going to enter in the hours for all 5 of my employees. It's going to show, all the hours that they worked. But now it's going to add this next line that's going to display a sum of all the hours that were worked by my employees. Okay, so 10 hours for everybody. Just keep it easy. Okay, there we go. So we display the contents of the array, and we summed the contents of the array. So all 5 of my employees worked 50 hours for this week. Okay, what if I want to know the average? Average hours. Well, all I have to do now is divide the hours worked by the number of employees that I have. Okay. All right. Now if I do this, 12 for the first guy, 11, 13, 10, 7. Nobody worked very much this week. Okay. So there we go. We display the elements of the array. We've summed up the total hours, and we found the average of the hours of the values that are stored in all the elements of the array. All right. Okay, so not only can we use integer literals for subscripts, such as 0, 1, 2, 3, 4, we can also use variables. Okay. So let's say that I wanted to make a variable I, okay, and I set it to 0, or initialize it to 0. I can then use that I, employee 1 worked, as the subscript. Okay, hours I. Okay. So let's take a look at that, right? So this should display the hours worked by my first employee. Okay. Okay, so we're going to say 33, 10, 10, 10, 10, right? So just as if I had put a 0 in there instead of the I, the subscript is utilized, right? The variable subscript is utilized just as if it was 0, and we return the value stored in the first element of the array. Okay, so I can change this variable I to something else, and it'll still work. All right, so our subscript 2 is the third element of the array. So Now, instead of showing the first element, right, we're showing the third. So 33 hours is the value that's stored in the third element of our array, and there it is. It's displayed. So maybe you can see where this is going. Okay, we can make this whole process much easier by using for loops. Okay, so let me comment out this stuff and rewrite it using for loops. Okay. Okay, so now if I want to add hours for my 5 employees, I don't have to write so many statements. Okay, I can do this. Okay, for I equals 0, I less than 5, plus. Let's prompt the user, enter hours worked for employee I plus 1. Okay, and then we put LCN hours I. Okay, so what's going to happen here? What's going to happen here is that this for loop is going to run, it's going to iterate 5 times, and it's going to start off at I set to 0. Okay, so my cout statement is going to say enter hours worked for the employee, and then it's going to show I plus 1. Okay, so in this case, the very first iteration, I is going to equal 0, so this is going to say enter hours worked for employee 1. Okay, and then it's going to prompt me to enter in some value, right? And so I is set to 0 through the first iteration, so I'm going to read in the value and store it in the first element of the array, which is subscript 0. Okay. So let's compile that and just try it. Okay, so there we go, just like I said. Enter hours worked for employee 1, I'll say 10. Oh, but look at that. Now the for loop has iterated, it's incremented 1, or excuse me, it's incremented I by 1, right? So now I equals 1, so now it says employee 2, and it's going to be storing whatever I enter into the second element of the array, which has subscript 1. Right? I is now equal to 1. So I can say 20, 30, 40, 50. Okay? And then my pause. So with this for loop, instead of having to write 10 lines of code, I just wrote a for loop that basically does the same thing. Right? So now what if I want to display the contents of my array? Well, I can use a for loop again. Plus plus. And this time I can say cout hours worked for employee I plus 1. Okay. And I'll do this. Okay, so what's going to happen is I'm going to enter in my hours for the employees, right, like before, but once I'm finished with that, then this for loop is going to print out the hours worked for each employee, right? I'm going to have 5 lines of output, even though I've only written 2 lines of code. So let's test it. All right, so my first employee worked 10, 20, 30, 40, 10. Okay, and so bam, there we go. Okay, so I've replaced, so what I've done is I've replaced all of this, okay, with just this. Pretty cool, at least I think it is. Right? Okay, so I showed a sum of the number of hours worked. Okay, I can also use for loops to do that. Okay, so I can say for I equals 0, I less than 5, I plus plus. Okay. But I'm going to use an accumulator here, okay, to help me with this summing. Sum equals 0. And I have to initialize it to 0. If I don't, then there's going to be some garbage value left over inside of the sum variable, and it's going to add all my hours to that, and I'll get the wrong total. So say 2 million was stored in sum, right? Assuming I didn't initialize this thing. If I didn't initialize it, say 2 million was in sum. Well, when I'm done adding all my hours to it, then I might have something like 2,050,000 or 2,070,000. Okay, so that's why we have to be sure to initialize sum to 0. Okay, and so I'll use a single statement here. Sum plus equals hours I. Okay, so what's going to happen is in the first iteration of this loop, this statement here is going to add the contents of the first element of the array to my sum accumulator. The next iteration is then going to add the contents of the second element of the array to my accumulator. The third iteration, the third element, etc., until I have the entire sum of the array. Okay, so then I can do a single cout statement. Total hours worked, and I can just print out my sum. Okay. Alright, so let's try this thing, see what happens. Alright, so employee 1 worked 10.5, employee 2 worked 20.25, employee 3 worked 17, 18, or 18, 170 hours, and 22. Okay, so there we go. We have my total hours worked, and I show all of the hours worked by all my employees, and we've used for loops to do all of this. Alright, so now if I want to show the average hours worked, all I have to do is divide by 5. Average hours worked. Okay. Sum divided by 5, so that's 5 employees. Alright, so let's try this again. Alright, so 22 for my first employee, 33, 44, 22, 33. Okay, so there we go. We show all of the hours worked, right, for each individual employee, and then we sum the total hours worked, and then all we have to do is divide that sum by 5. Okay, what's going on here? Average hours worked. Oh, I have a problem here because integers, right? Integers divided by integers equals integers, so I lost my floating point number, so let's fix that. Okay, that was my problem. There's a bug. There's a bug. Okay, so let's try this again. Okay, 22, 33, 44, 22, 33. Okay, there we go. All good. Right, so there's an example of, accidentally storing a value in the wrong data type. Right? I lost my floating point number when I tried to store an integer, or tried to store a double into an integer. So that's fixed now. Okay. Okay, so the last thing I'll talk about is default initialization for a global array versus a local array. Just like with global and local variables, we can have two different types of initialization for an array based on whether or not it's local or global, right? So let's comment this stuff out so we can start off fresh. Okay, so let's say I just made an array of characters called name, okay, and it's going to be 20 elements long. Okay, so this array named name is local to main. Okay, it is declared inside the main function. That is where its scope lies. Okay, it is local to main. So this is a local declaration, which means that by default it is not initialized to anything. So when the memory is allocated for this array, whatever values happen to be in those memory locations are still going to be there. So let me show you what I mean. Okay, let's write a for loop to print out all the contents of this array. Okay, cout name and some spaces, just so we can space the thing out. Okay, so why do I have squiggly lines? I should. Oh, I forgot my I here. Okay, so let's try it and see what happens. Okay, so you see in those memory locations there are values for the ASCII table that give us these characters. All right. So we didn't put them there; they were just there. They were left over from some other program. Okay, so let's close that. Now, if I change this to an integer array, let's see what it prints out. Okay, and so we see all of these numbers here. Okay, we didn't put them there; they're just there. That's the point. So, if we want to have values there that we know what they are, then we have to manually put them in there ourselves. So maybe what we do is we write in a loop that initializes everything to 0. Okay. Name I equals 0. Okay. Oops, J. Sorry, I changed it. J. Okay, so now when I run this, right, what's happened is I wrote this for loop here, and it's going to set all of the elements to 0. Okay, so when I print it out, they're all going to be 0. See? Okay, so there I've initialized it manually. So that's the situation with local arrays that are local to a function. Okay, but the behavior changes if we make the array global. Okay, there is a default initialization that's done, and that default initialization is it sets all the values to 0 for you automatically. So without having to write another for loop to set the values of each element to 0, it's going to be done for us because the array has been declared globally. Remember, anytime you declare something globally, all that means is that you are declaring it outside of all of the functions in your program. And int main is a function. Okay, so I've declared this array outside of int main. That makes it global. So now if I run this thing, you can see that they're all still 0, even though I didn't manually or explicitly set them to 0. Okay. Alright, so there's one last thing I wanted to show you, which I forgot. Let's just move this back here. Okay, and that has to do with my loops again, right? So let's say that maybe the number of employees I employ could change. Maybe some of them are only seasonal or something like that, right? Normally, if I wanted to change their hours, I would have to go in here and I would say, okay, I just hired 5 people. So now I have to go through here and I have to say, okay, 10, gotta change that there, gotta change this one, gotta change this one, gotta change this one, right? Because if there's now 10 employees, I now have an array that has a length of 10 elements, and I have to go through and change my for loops accordingly, right? I even have to change my value down here, right? Because my average needs to be divided by 10 now since I have 10 employees. Okay, that's kind of a pain, right? So we can do something differently. We can use a const integer. Okay, remember we used a const integer for the declarator in the earlier example? Well, if we do it again, suddenly this becomes much easier. Okay, so let's say that I make this const integer numImp. Okay, and I set that to 10. Okay, and now what I'll do is I will use this for my size declarator, and I'll use it for my for loop control expressions, and I'll also use it for my average that I'm going to find here. Okay, so now if I have 10 employees and I lose a couple, all I have to do is change this one literal here, this one integer. Okay, and it's like making a change in every other portion here. Right? So instead of having to go through and type changes for what, 4 changes, 5 changes, all I have to do is make one, and I know that it's going to work for every single one of these loops, for this average here, and for my declarator. One one change, and I know it's going to work. So let's go ahead and run this thing and test it. Oops, I still have the leftovers from my previous thing, but that's okay, we'll just ignore it. Okay, so the number of hours worked for employee 1, let's say 30. Employee 2, 32, 30, 29.5, 30. See, it's iterating through all the way up through my number of employees. That's my constant integer. Okay, this one worked 22, 17, and my last employee worked 18. Okay, so all of my values, the hours that my employees worked, have been entered in the array. The for loop iterates over and prints out all of the hours for each individual employee, finds my total hours worked and the average hours. Okay, so now let's comment this out so we don't see that garbage at the beginning again. So let's say times were tough, I had to let 5 people go. Okay, so all I have to do is change this 8 here to a 3. All right, so now if I run this thing, employee 1 worked 22 hours, employee 2 worked 17 and a half, and employee 3 worked 18 and a third. Okay. So bam, there we go. Everything works great. Okay, it only prompted me 3 times to display the hours for 3 employees, the total hours worked, the average, all that stuff, right? So much easier. Okay, much easier to make a change if you use this const integer, right, for your declarator and for your for loops. An average, one change instead of what was it before? 1, 2, 3, 4, 5 changes, right? So this is a time saver, and it also lowers your chance of introducing bugs, right, by forgetting to make changes everywhere you need to make them. So it's really efficient, and it's a great way to do this. So I think I'll stop there for this lesson. We talked about what arrays are. Okay, they are just variables that can store multiple values of the same data type. Right? We talked about some terminology, the name, the size declarator, subscripts. We talked about using const declarators. I showed you how to access array elements, how to declare the variables, the array variables. I showed you how to find the size of an array in terms of bytes. Right, just the size of the data type for the array times the number of elements, right, or times the length of it. Okay, and we used loops to make things a lot easier. Okay, so we'll talk about this stuff more this week, and you're free to review this video as you need to. Hopefully it will be helpful. All right, so next time we'll talk about, I think the next lesson we'll talk about bounds checking, we'll talk about we'll talk about array initialization, implicit array sizing, summing and averaging we've already done, so we're kind of ahead of ourselves on that. I'll show you an algorithm for finding the lowest and highest value in an array and how we can compare arrays. Okay, so that's it for now, and thank you for watching.